Hello, everyone, and welcome to the Anti-Doping Podcast, brought to you by the Partnership for Clean Competition. I'm your host, Dr. Marie McNeely, and today we are joined by our guest, Dr. Sven Voss. Listeners, Sven is director of the Institute of Doping Analysis and Sports Biochemistry, or IDAS, in Dresden. This is a World Anti-Doping Agency, or WADA, accredited doping control laboratory in Germany. And Sven, we are so excited to have you with us today. How are you?
Good afternoon, Mary. Yeah, thank you. I'm very well. Thank you so much for the invite to your show.
Well, we're excited to hear more about you and more about the wonderful work that you're doing in anti-doping, but perhaps we can start by just learning a little bit more about your background, Sven. Can you tell us more about yourself and how you got interested in the field of anti-doping?
Well, I've been a track and field athlete when I was a little bit younger. And at that time, I was already interested into science, and there was no internet. And I went quite often to library, and I found a book about anti-doping, which was published by the German Athletics Federation. And I found that very fascinating. And I couldn't think about that athletes would take all kind of medications to improve their performance. And I would say that was somehow the start, which got me interested in that field. And then I tried to get more information, found more books. One which I found very impressive was called, I would translate it into Doping from Science to Cheating, which is written by Brigitte Behrendonck. And she basically describes in her book what happened in West and East Germany before the 90s, including also the organized doping in the former GDR. And then I went to study sports science at the German Sport University in Cologne. And somehow, by chance, I ended up in the anti-doping lab as a student assistant.
That's awesome. So how did that opportunity come about?
I was basically looking for a job as a student, and they were looking for assistants. And I applied, and I wasn't sure if I got the job. So I asked and followed up. And then they said, oh, yeah, you're the first one following up. So yeah, we give you the job.
It pays to be proactive, I think, right?
Yeah, probably.
Well, I think that is remarkable. And I know you've had a particularly interesting career path, Sven. You've had the opportunity now to work at different anti-doping laboratories over the years. And you started there actually at the WADA accredited laboratory in Cologne. Can you tell us a little bit more about this laboratory and what it was like for you to work there?
As a student, for me, it was really a fantastic time there. I started when WADA was not having such a regulatory role. So somehow I had the chance to experience how the whole system in anti-doping was reshaped and more harmonized. And starting as a student assistant, I was working first in the sample reception. I moved to different analytical areas and finally ended up in what we would call the biological field, which included EPO, growth hormone, homologous blood transfusion. And then I was asked by Willy Schenzer at the time if I wanted to do my master's thesis there, which I did under the supervision from Andrea Gottsman and Mario Tevis about HBOX, hemoglobin-based oxygen carriers. And what was really cool is that Mario returned at the time from US, where he did his postdoc, and he brought quite a bit of knowledge about protein analysis, which helped me to do my master's. And then finally, I did also my PhD under Willy Schenzer in the lab in Cologne, which was then about blood and EPO doping. And I really believe that Cologne is a place to go when you want to learn more about analytical techniques, because there are so many highly experienced staff. And because they are based at a university, there's this attitude of sharing and teaching. It's fantastic.
Well, that sounds remarkable. And the next stop on your career path, you then accepted a position at Aspire Academy, which listeners may not be familiar with, and established the Sport Biochemistry Lab there. So can you talk a little bit more about what is Aspire Academy and what was this experience like for you, and what research were you able to conduct there?
I was basically planning like a 1-year exchange to improve my English, to get a bit international experience. And the Aspire Academy for Sports Excellence in Qatar, I would say it's really unique in the world. The facilities are all under one roof because it's very hot outside. It's Qatar. But you can imagine there isn't complete athletic tracks. There are multiple gyms. There's a 50-meter indoor pool. There's a real FIFA-sized football pitch indoor.
Oh, wow.
There are hypoxic chambers. There's physiotherapy, a recovery center, complete sport science area. And my role at the time was to set up the sport biochemistry lab. This included then instruments for routine testings for parameters such as creatine, kinase, or urea, which was used to monitor the muscle stress of the athletes. And also, for example, testosterone as a marker for puberty. We did also like hematology analysis and hemoglobin mass tests to monitor adaptation to the hypoxic interventions, which were done there. During this time, I was, of course, still interested in anti-doping. And then the World Indoor Athletic Championships in 2010, they came up. And I contacted Neil Robinson at the time, who was working in the lab in Lausanne. And we arranged that my lab in the Spy Academy became a satellite lab of the laboratory in Lausanne. So we could conduct all the ABP tests of the championships there. And study-wise, one of the best things we did there was a project which was done together with Olaf Schumacher, who was at this time still in Germany at the Freiburg University. And what we did there was to arrange a simulated Tour de Qatar with German cyclists and triathletes to investigate the effect of changes in plasma volume on the biological passport due to the heat and due to the high intensity and high volume of exercise. And I can remember very well because the infrastructure for cycling was not very good. The cyclists had to basically cycle on the highway, and we arranged a police escort. So we had police cars behind us to conduct the study. So that was one of the cool things I remember study-wise there.
I think that is remarkable. So what were your findings then?
Oh, it was a really clear increase in the plasma volume. We could see changes in the hemoglobin concentration of 1 to 1.5 gram per deciliter. And we tested the athletes 2 times a day over almost 14 days. And there were a lot of findings, for example, that at the end of the day, we took too many blood samples. And after 9 days, we basically stopped taking the data into the interpretation because the hematopoiesis was increased from all the blood we took.
Oh, no. I think sometimes you learn some unexpected lessons in these experiments that you do.
Indeed.
Well, this sounds like a remarkable experience. And then you actually moved to the anti-doping lab, Qatar. Can you talk a little bit about that transition and what it was like working in that WADA accredited laboratory?
So initially, I was not planning to go to the anti-doping lab Qatar. And I remember I was asked 3 times by the general manager there, do you want to come? And he asked me another time, do you want to come? The third time I said, you want to come, right? And I said, okay, I'll move over. And then it was really an interesting time because building a laboratory completely from the scratch is quite a task. And I remember we were sitting, I think 1 or 2 years in a container building next to a construction site. Kostas Georgopoulos, who was the director in Essence, came to be the director of the lab. So I was working with him. And yeah, it was a planning phase related to the building requirements, about the necessary equipment, the work process in the lab, the manpower we needed. We started creating a QM system with standard operating procedures, working forms. And I remember that we moved into the new building. And I guess like in any new construction, things were not ready as they should be, and then we had to move out again. And after 2 months, we could move in again. So It was quite a journey. And then starting with the staff over there. So we had to train all new staff. And we were lucky because they brought some experience from the medical labs they worked before. And some did also some study in biochemistry. But of course, they didn't have any anti-doping background. And to create this mindset about anti-doping, this takes quite some time. And it worked really well. We had a really good team together with Kostas, and I should mention also Ariane Bonaparte was coming also from the Greek lab, who was responsible for the LCMS section, and Rodrigo Aguilera, who came to help us with the IIMS section to improve that. So yeah, it was quite an experience there.
It sounds like it. It sounds like it was quite a process, as you alluded to, building this laboratory from scratch. How long did it take from the moment that you started working on this lab building project until you had kind of a well-functioning lab there?
I would say between 4 to 5 years.
That's remarkable. And you were there for about a decade. So it sounds like you had some good time working in the laboratory. But then you actually moved to Dresden, where you are now. How did you find out about this opportunity and make that big decision to move back to Germany?
Actually, we were quite happy in Qatar, but we had kids and they were starting to get to the age going to school. And I wanted them to learn proper German because at home we speak English. And at the end, I think what really made us leave Qatar was the COVID pandemic, because we were stuck in Qatar for almost 2 years. We were missing family and friends back home. And then during that time, I already contacted a few people to inform that we were maybe interested to move back to Europe. And one day, Dr. Detlef Thieme, the former director of IDAS, he contacted me and he said, I heard you might be interested to move and I'm going to retire soon. Would you be interested to apply? And this is what I did. I applied and at the end I got the position here.
I think that's remarkable. It seems like a theme that's come up a couple times in your career path where just this perfect position seems to be right there when you need it.
Yeah.
So that is wonderful. And you've been at IDAS now for a couple of years. Can you tell us a little bit more about IDAS and what it's like working there?
Historically, IDAS was initially part of the sports medicine services of the former GDR. And they were also performing some kind of pre-testing of the athletes before going to international competitions to avoid testing as a positive. So it was some kind of dark history, if you want to say so, which then, of course, changed also when Germany became reunited in the 90s. And IDAS is only one of two institutions in Germany for which the German government then decided to keep it and to support it. Then IDAS, as IDAS, was then founded in 1992 with the independency being monitored by a board of trustees. And in 1999, it became a WADA laboratory with ISO accreditation achieved in 2000. And now we have currently 25 employees and analyze every year around 14,000 samples.
Now you've had these experiences. We sort of walked through them working at 3 different WADA accredited labs. So I'm curious to get your insights here. Sven, how are these different WADA accredited labs around the world maybe similar and different from each other from your experience?
Apart from having worked in 3 different labs, I also had the chance to participate in some WADA and ISO audits of other laboratories. And actually, whenever I have the chance to visit a lab, like during conferences or holidays, I always try to arrange some time to do a visit. And I believe that there are many things in labs which are extremely similar due to the harmonization by WADA and its standards. But you always find these little things where you think, oh, this is a really nice idea and I could make work or processes much easier or more efficient in my own lab. And if you compare labs, for example, Cologne is, for me, an example. It's clearly a center of excellence in anti-doping research. While, for example, in Qatar, I believe we had an excellent quality management and documentation system. And here in IDAS, for example, we have a specialization in the analysis of hair, which is even in our ISO scope. And this is utilized also in many criminal cases here in Germany, where, for example, steroid abuse could be related to violence, and received lately some samples from murder cases.
Oh, very interesting. And I think so far we've made it all sound easy. Just these great positions pop up, things go smoothly, but there are a lot of challenges involved in running and working at even a WADA accredited anti-doping laboratory. So Sven, could you give us some details on what you see as some of the biggest challenges in your job?
I feel that, especially over the last decades, running a WADA lab has become incredibly complex. The WADA standards include now technical documents, technical letters, technical notes, guidelines, and so on. And these documents are all very detailed and they're kind of living documents which constantly evolve. So it's hard to stay up to date. And sometimes I really wonder how people who are new to our field, who don't have the history, can manage this, especially if they don't have this years of experience. So to find competent people or train new people for the job, this is not an easy task. Another point is, of course, that there are more and more substances developed in the pharma industry, which potentially can have performance-enhancing effects, and they end up on the list of prohibited substances. And we are currently testing 300 plus substances, and for every new substance, we can be happy if it's possible to integrate it to existing screening procedures, because otherwise new and specific methods need to be developed, and this costs time, manpower, and instrumentation. So the time that you could run the lab with just one GC or LC is unfortunately long over.
Well, that makes sense. And what helps you overcome some of these challenges?
Well, on the one thing, it's the experience we have here. We have good support of our government. So infrastructure and instrument-wise, we are quite well. And of course, the colleagues we have here, they are specialists in what they do. So this, of course, helps.
Definitely. Well, let's talk about some of the strengths of IDAS Dresden. Can you share, Sven, now that you've been there for some time and you have, like we said, other labs to compare it to, what are some of the things that you think that IDAS does particularly well?
The first thing at IDAS, what is great, is a number of staff with decades of experience. And this is not only in the field of anti-doping, but also in hair analysis. Another thing is that we focus very much on our customers with offering fast turnaround times, consultation in difficult cases. And historically, some of the staff was studying also and became some kind of forensic toxicologists. So we have quite high number of people trained in that field. And I think this is something what we do particularly well.
I think that's wonderful. And we've touched on some of your research experiences over the years. And I think it's important to just think about where research fits in the field of anti-doping. So Sven, why do you think it is so important to continue working to advance anti-doping science?
Anti-doping is constantly evolving. There are new substances, new methodologies which can be used to dope. There are also new analytical processes and new instruments which come on the market, which might help to improve our testing. And all this needs to be tested, and this requires a constant work in this field. And apart from that, I believe also that this research is a fun part of the job. And without having that, I think maybe some of our scientists would look for something else. If it would be just the routine testing, I think research is what makes us really interested in this field.
Definitely. I think the research can give you some opportunities to get creative and do more maybe problem solving than you do with routine work.
Exactly.
So let's talk a little bit more about the research that's going on there at IDAS. What are some of your research priorities at the moment, and what are some of the projects that are ongoing?
In the past, there was a focus here on generation of certain metabolites, for example, by cell culture. And this was established in collaboration with the Technical University here in Dresden, which we are also an associated institute. And then also with other collaborations like with the lab of Maria Paar. Then another priority is here the field of hair analysis. Then we had some, for example, quite applied research projects like method developments and validations, or recently also some research on ashwagandha, which is a supplement which is based on a plant, and the effect of this supplement on steroid profile. Because the question for ashwagandha came up when we were discussing with the German NADA, so that this supplement can be seen more and more in the doping control forms. But I mean, my background, as I said before, is more in the field of blood and EPO doping. And my aim is therefore also to broaden a bit our scope and put this also in the focus.
Oh, very interesting. And you mentioned a couple of different areas or projects. Is there a particular project, Sven, that you are working on right now that you are particularly excited about and want to tell us about?
We have a couple of projects related to EPO at the moment. And one study which I find particularly interesting is one in which we investigate the effect of recombinant EPO on the morphology of red blood cells. For that, you are utilizing artificial intelligence and the interpretation for blood smears. And blood smears is not a matrix applied in the WADA scope, and it's currently only used in clinical settings. But I found it interesting because you can generate blood smears from capillary blood. And the smears are quite stable and they don't need to be cooled, so they can be sent to the lab without cooling and within a couple of days. And the idea came up when I met with the local hematology department here at the university hospital, because they have a working group which is specialized on digital morphology, AI, and cancer research. And they were investigating white blood cells. And then during the meeting, we said, hey, why don't we try if the AI discovers some changes in the red blood cells if subjects are treated with EPO? So we prepared a grant application and at the end get quite lucky to receive funding from WADA for this project. And this was then performed in collaboration with the Department of Sport Medicine of the University of Bochum. And they organized basically the clinical trial there with sports students as volunteers. And now we just finished this project and the results look really interesting as the AI was able to differentiate non-doped and EPO-doped subjects. But at the moment, we are still not sure what exactly are the parameters which the AI picked up. And I believe that if we really want to go one step further and use such technologies in anti-doping, we must understand what lies behind these algorithms and what is the biology behind. And also, to be frank, the number of volunteers in this project, it was okay to get some pilot data, but I guess there's definitely more needed. So there's still a lot of work to do, but overall very, very interesting and novel.
Well, I think this is a fascinating project, and perhaps we'll rewind a little bit. You mentioned blood smears. This is something, like you said, that's not routinely used in anti-doping. How does this compare to dried blood spots, which listeners might be more familiar with?
Well, it's basically a dry blood spot, but it's not lice blood. You put a drop of blood on a glass and create this blood smear. It dries, so it's basically like dried blood, and you can send it in.
Very interesting. So it's almost like a little like microscope slide, those glass plates.
Yeah, exactly. It is a microscope slide.
Okay. Very cool. Well, this project is remarkable. And I think the incorporation of AI into anti-doping is a interesting area of study. What challenges did you encounter in trying to develop this AI model, which could differentiate between doped and non-doped blood?
Well, I'm not a statistician. I'm not an AI specialist. And when I started this project, I was thinking it's much easier. There's a clear outcome. We can see later the microscopic images and can see what AI discovers. And then while doing such a project, you realize, oh, well, it's not that easy as you think. But I think that's how you start. And for now, this was planned as a pilot. We get interesting data, but it's really necessary to learn more. And I think in general, we should be also a bit cautious because AI is something which is a bit en vogue. I mean, we had the idea, I think it was in early 2023. So there's some time which went by. But I think there are quite a few research projects going on in that field. And I think many discover similar things that what you thought before AI could offer could be already done by HI, human intelligence. Then the other thing is that to go in front of court and defend an AI result, you really need to understand what is behind. This is, I think, one of the challenges.
Definitely. And you explained that you kind of got this result where it was successful in differentiating the images, for example, of individuals, their blood who had been doping versus those who had not been doping with this recombinant EPO. How do you start to tease apart then what features that AI is picking up on in those images? I know there's examples sort of as cautionary tales of it picking up on artifacts or non-biological characteristics of these images. How do you start to figure that out?
This is exactly the point. We had now, when we talk about features, we had heat maps with microscopic images, which basically showed which areas the AI picked up. And this is the point where we are right now. So we have to dig deeper into that.
Well, Sven, I think this is fascinating and definitely something for our listeners and myself to keep an eye on as we await more results coming out of the laboratory there. But I think thinking about the future, there's a lot of different questions and a lot of different areas in anti-doping that you could work on. What are some of the goals that the lab is working towards, perhaps, for example, in just the next 5 to 10 years there?
Let's say the building we are in right now, at the time it was built state of the art, but today, because of all these new methods and all the requirements by WADA, we started to lack space. So I was happy that our government now also realized that and is trying to support us to find a new facility. So in the next 5 to 10 years, I think we have to work on a new location, setting up a new lab. Then, of course, over the next 5 to 10 years, the long-term goal is to continue offering excellent services to our clients and to extend our research output.
Well, it sounds like you've got some exciting things on the horizon there. A move can be a little bit daunting, but you're familiar, of course, with building this lab from the ground up.
Not the first one, yeah.
Is this something that you're looking forward to or perhaps maybe dreading a little bit?
No, it's okay. I'm looking forward to that.
Well, it sounds remarkable. We'll have to touch base with you then again later once you're in your shiny new facilities. And we've talked a little bit in our conversation today about some of the collaborators that you've worked with over the years. And I think collaboration is critical for anti-doping. So Sven, can you give us some details on just how the lab there at IDAS works with other stakeholders in the field, whether it's national anti-doping organizations, the PCC, other labs, and other anti-doping scientists?
We have a very good relationship with all NADOs we work with and also too many laboratories, which is probably also due because I'm working for 25 years now in the field. And I would say with the German NADO, the collaboration is really excellent. We have regular meetings to discuss what are current problems in testing, what is new in the field in regards of methods and substances, and how to improve the general work of anti-doping in Germany, being testing, athlete sample collection. In regards of laboratories, for example, we had just last month a visit from the laboratory in Barcelona where we were sharing some knowledge related to our LCMS instruments. And now in 2 weeks' time, for example, we have Ximiao Zhu from the Beijing lab coming to our lab to help develop the reverse immunopurification EPO method, which is to detect this EPO variant to exclude false positive findings for mutants. And I believe that the sharing of knowledge in our field is super important. And in regards of WADA and the PCC, they are the most important funding bodies in our field, especially because as a lab, we are so focused on anti-doping topics. And it's sometimes hard to get fundings from other agencies or funding bodies. And yeah, I've been now to 3 USADA conferences, and this is something I enjoyed a lot. It was really nice to meet scientists there, which are not coming only from the anti-doping, but also from outside of this typical lab circle, such as people from pharma industry, from universities, from clinical settings. So this is great for exchange.
That sounds wonderful. And I know that you, Sven, are part of two different WADA working groups. There's the EPO working group and then also the homologous blood transfusion working group. So I'd love to talk about those as well. Can you maybe introduce listeners who aren't familiar? What is the purpose of the EPO working group?
Well, the method to detect the use of recombinant EPO is based on electrophoresis and Western blot. And the difference between recombinant and endogenous is dependent on the applied technique. So if you use isoelectric focusing or IF, there will be different isoforms, either in the more basic or acidic area. But the technique which is mostly used nowadays is the SARPage. And this differentiates by molecular weight. And due to the different glycosylation of recombinant EPO, the migration is in the area of the higher molecular weight. And today, for example, the IEF has been mostly removed because it's easily affected by exercise-induced effort urines, which can result in suspicious findings. And in addition, the IEF is also less sensitive as the total amount of EPO is divided into different isoforms, which is not the case in SARPage. So the detection window in SARPage is better. So the method has been developing now since its introduction 25 years ago, and the EPO working group is responsible for the review and creation of the technical document EPO. So we meet on a regular basis to discuss what is new in the field, what research is done, and what could potentially improve the method. The members of the working group work all for many years in the field, have seen thousands of samples from routine analysis, but also from excretion studies. So we act also as a second opinion provider and review all the suspicious EPO cases coming from all WADA laboratories.
Very interesting. So how often does the group get together? And I guess what is the time commitment for this group? It sounds like quite a bit of work.
We won't get together too many times. It's approximately 2 to 4 times a year. Mm-hmm. This can be in person. This can be also online. But the amount it takes to review and write new technical documents is a lot because we are not every time of the same opinion, and to find a consensus which reflects everyone's opinion or which is the best way to go ahead for all WADA labs. This is certainly not an easy task, and especially the document EPO is a very complex and long document.
Definitely. And I know research is still ongoing in this EPO area. And we mentioned that the other working group that you're part of is this homologous blood transfusion working group, which maybe has a little bit of overlap just in terms of the focus on the blood component. So can you talk about why this group was developed and what are some of the tasks that you do as a member of this group?
The homologous blood transfusion working group is really quite new, but the responsibilities are basically the same as in the EPO working group. So here the method is based on flow cytometry. So it's very different to all the mass spec, which is mostly in place. And with this technology, you can analyze the properties of whole cells. And in our case, the focus is on red blood cells. And they are what we call minor blood groups. So the differentiation of doping versus not doped is basically based on the fact that either you have a blood group or you don't. And a sample becomes suspicious when there are red blood cells in your blood, of which some have the blood group and others don't. So it's basically like a double population. And this indicates doping. And at the moment, we are working very hard to create a technical document. So far, the method is only regulated via the International Standard for Laboratories. And it will be really good to have something laboratories can follow, especially when they are trying to develop and implement this method in their lab. And it's a method which is necessary, for example, for Olympic Games. So every lab analyzing samples for Olympic Games has to set up this method. So it's good to have a guideline or technical document in place.
Well, that makes sense. And you mentioned this HBT homologous blood transfusion working group is relatively new. How does WADA go about deciding what new working groups are needed, or how did you become part of this working group?
I was basically one of the first people setting the method up in a WADA anti-doping lab, and one of the few having a publication in that area. So I remember, I think in 2006 or 2007, I set this method up. It was part of my PhD. The other lab, which already had the method running, was the laboratory in Lausanne. And at that time, the scientist, his name was Sylvain Giron. He was one of the experts. So it was basically him and myself who were then also invited to Olympic Games like in London to see if the method is set up properly and works really, really well. And then those laboratories having experience with the methods, and this is unfortunately only a few because the method is not regularly mandatory, they were invited to join that working group.
Oh, very cool. Well, Sven, we appreciate you sharing some of the remarkable work that you've done over the years. We've touched on some of the research you're doing now as well. And I think in anti-doping science, like in any other field, there are often limitations. We touched on funding, but I think just the feasibility, trying to get the samples you need, there's a ton of different complications and barriers in a lot of cases to being able to answer the questions you want to answer. So if we took away the barriers that normally hold you back, Sven, and you had all of the resources you could imagine, what is the one problem in anti-doping science that you would most want to solve?
If you would have asked me this question a few years ago, I would probably have answered with finding a way to detect autologous blood transfusion by a direct test. But today, I feel that the problem in science, in anti-doping science, is in fact the limited resources. So there are more and more areas in anti-doping which become relevant, such as intelligence, social science, education. Also, the cost for legal cases, they are becoming very high. So all these areas, they are all important, but of course, they affect the overall resources. So if a NADO needs to employ investigators or educators, this means that at the end, there's less budget to collect samples and to perform tests. So the one problem I would like to solve is how to change the mindset in the big sport companies. They're willing to pay millions of dollars to athletes, but somehow they are not willing to support clean sport in a really appropriate way. I mean, how can it be, for example, that the complete WADA annual budget can be less than that of a professional soccer player? This is something I would like to solve.
Definitely. I think just this idea of how can we drive more investment and interest in anti-doping is a big one for the field for sure.
Exactly.
Well, we appreciate you sharing your perspectives with us today, Sven. If we've captured the attention of our listeners and they would like to learn more about you and what you do, what is the best way for them to do so?
Well, if you Google the IDAS, Institute for Doping Analysis in Sport Biochemistry, you come to our homepage. And although it's not really the news, but you will definitely find email addresses to contact me. But also if you check on PubMed, my name, you will find that there are quite a few publications where I'm involved in and where you can find some contact details to contact me.
Perfect. Well, we appreciate you sharing those resources. Listeners, definitely take some time to check out some of Sven's past papers. Visit the IDAS website to learn more. And Sven, it's been such a pleasure to have you on the show today. Thank you so much for your time.
Thank you.
And listeners, it's been wonderful to have you here with us as well. Please note that the Anti-Doping Podcast features a wide variety of clean sport experts, and episodes may include statements and or viewpoints that do not necessarily reflect the views or values of the PCC. Thank you, and we look forward to seeing you on the next episode of the Anti-Doping Podcast.